Well, thanks everyone for coming. I'm Edward Su, VP of Product Marketing at Mesosphere. This is Randy. And we're going to talk to you today about DCOS and Mesosphere. A couple of things I want to make sure we cover include not only how DCOS can help customers facilitate digital transformation, but also better manage all the technologies that are changing in their ecosystem. We're going to walk through a demo, and then towards the end, feel free to ask any questions. So, all of us are going through this transition of dealing with modern enterprise application architectures, and of course, cloud is a huge factor that all of us are managing today, right? Customers are thinking about cloud infrastructures. Cloud providers are really changing the landscape, and there's three main factors that I think a lot of people sometimes forget. First, the applications and the way they're changing actually means that software now is a larger differentiator than it ever has been before, right? So while you have some companies still focused on getting ITIL up and running, you have others that are building customer-centric, data-driven applications. Secondly, the pace of change is actually accelerating, right? Who would have guessed 5 years ago, Hadoop would be playing less of a role compared to Spark? And what's going to be the main tool being used for analytics 5 years from now? None of us really knows. What we do know is that the pace of change is going to accelerate. And then lastly, there's this blurring line between competitors and cloud providers, right? Many companies now have a lot of information on their customers and can very easily enter into other verticals. And that's why you have companies like Uber competing with auto companies. You have companies like Amazon that are buying Whole Foods and so forth. So a lot of changes, blurring lines between industries, and also cloud providers that you depend on may actually end up being a competitor for you. So those are the factors a lot of us have to deal with as folks leading technology in organizations. So a couple of things I want to talk about. First is, what is the nature of this data-driven application architecture, and what are the implications to businesses? Second, how do you enable a cloud-like experience for running these type of applications on any type of infrastructure, right? Whether it be your AWS cloud, on-prem cloud, or other third-party cloud providers that you're using. And then Randy's going to walk you through DCOS, doing a live demo of a connected car infrastructure simulation. And then lastly, we're going to talk about open source, because we see ourselves at Mesosphere enabling an open source ecosystem, which we actually find very important to the future of open source in general and also for innovation. So let's kind of get right into it. Application architectures definitely changed dramatically in the last 10, 15 years. When I started out my career as a developer in the .com era, this was what an app looked like, right? You had a monolithic code, packaged software, you had a structured database, and your users were employees generally. And if it took 6 to 8 months to get new features rolled out, that was actually totally okay. That's definitely not the case anymore. Most companies now have to build connected customer applications. So I'll give you guys a challenge when you guys go home today. Count the number of network connected devices in your home. It'll probably be more than you expected. So I read this report that the average North American home has 15 connected devices. So I thought, this analyst is probably just inflating numbers. I'm going to go home and count. And I counted 23 devices. Because there are things like your vacuum cleaner, your electric shades if you have that. I'm a dad now, so I have Nest Cams, right? All these things are network connected. And what does that mean? It means companies that never had to build customer connected applications before, all of a sudden have to. Right? And being able to navigate this is actually very important. If you think about how software has changed many different industries, cellular phones, for example, right? The players that were great at making cellular phones initially were not the ones that are really good at it when software became a larger component of it. The same is true for digital cameras. Bought a digital camera recently, software experience is horrible, because I have expectations around my iPhone experience, for my traditional DSLR and those type of cameras, right? So that is the reality for many businesses today. It doesn't really matter if you're selling jet engines, cars, or whatever it is. You're going to have to build, network-connected, customer-centric applications. And the way the enterprise application architecture has had to evolve is to move towards distributed systems. And specifically, people are using distributed systems of containerized microservices, and also distributed systems in terms of data services, whether that be Spark, HDFS, Cassandra, Kafka, and so forth. All of these are key components that you have to figure out how to manage as an organization. And we're going to show you how that works on DCOS in a few minutes. So what does it take to be successful in running these type of applications? I would argue there's two main flywheels that you have to create in your organization. The first is being able to ship code very quickly, so that if you have new ideas, new services, developers can build, ship, package, and ship code to production and get them in front of the customer as fast as possible. So that can be, you can count that as your tactics, if you will. The second flywheel, which is also very important, is the ability to adopt new data technologies, right? So this is actually deciding whether your company is fighting with stones, sticks, knives, guns, or laser weapons, right? Imagine if your competitor had machine learning tools and you're still doing batch analytics, you're not going to be able to compete well with them. So, just by the way, by a show of hands, who thinks shipping code quickly is more important of the two? If you had to choose one that was more strategic, more important. Nobody? What about the data service? So one for shipping code more quickly. What about adopting new data technologies more quickly? Who thinks that's more important? Okay, a lot more, right? So I'm on the same page with you guys on that, right? I think all vendors that work with you are going to be helping you do containerized infrastructure, and Kubernetes is now increasingly becoming the standard by which we do container orchestration. There's also a lot of momentum behind tools like Jenkins to help people ship code, right? But in terms of the new data technology space, it's actually really complicated. And it's fast evolving and fast changing. So, the two flywheels, right, that you as an organization have to enable. Help your developers ship code quickly so they can ship microservices, build microservices architecture, create a CI/CD tool chain to enable DevOps. And then secondly, being able to adopt, internalize, and leverage big data services, whether they be analytics or next generation cloud native databases. Those are all things that all organizations, I believe, mainstream organizations have to get good at to be successful in this new cloud era. So how do you enable a cloud-like experience for these technologies? Because all those data services I talked about, they're all distributed systems in their own right. They're complex, right? They're cloud native, so they have expectations on how they're set up. But a lot of infrastructures that people have in their organizations are not that automated or that dynamic, right? So that leads sometimes people to think, well, I have to choose. I have to choose between keeping things in my data center and running all these data services in silos, or I can go to a cloud provider, but then I'm stuck in that cloud. And we at Mesosphere don't think that has to be a choice. We think that's a false choice. We think you can have the best of both, right? So when you think about the approaches to enable these container orchestration and data services, there's a couple of options, right? There's the traditional approach, which is the way our co-founders did it at Twitter and Airbnb before they had felt so much pain they decided to start Mesosphere as a company. At Airbnb, they were trying to roll out Cassandra. It took them a couple of, I think 6 to 8 months is what Toby, our CTO, said, right? Because you have to get the physical clusters, get them set up. The folks didn't really know how to use Cassandra, so there's a lot of work to be done just to get one vertical, one silo of Cassandra set up so developers can play with it. We're not even talking about production operations here, right? And then you have another one for Spark, container orchestrators, and so forth. You're solving for architectural control, and the drawback, of course, is manual operations and a siloed infrastructure. Now, if you're solving for speed, then you go to cloud, because you're outsourcing all of this stuff, right? The benefit of that is you can ship code very quickly, build apps very quickly, and if you're a startup just trying to get things going, that's probably the best way for you. But over time, this can come back to bite you. So Snap, the company behind Snapchat, filed their S1 as part of their IPO recently, and they actually shared publicly that one of their biggest business risks is their commitment to their cloud provider. In that case, it's a Google Cloud. So they're losing $500 million a year, $400 million of which is their commitment to their cloud provider. And their biggest business risk is their relationship with this provider. Because A, if the provider says, that data service you're using to power Snapchat, we're going to deprecate it because it no longer fits the strategic interests of our company. Or B, for whatever reason, we felt it necessary to raise prices of these data services by 25%, 50%. Or C, hey, guess what? We're going to enter this space and start competing with you guys, and we would like you to fund us to compete with you. If any of those scenarios happen, this company has no recourse. because they've built their app against these platform services specific to this cloud provider. So at Mesosphere, we think there's a third alternative, and that is to bring the best of both and through software automation, give you the flexibility to use any type of platform service from an open partner ecosystem and choose any infrastructure. That includes, by the way, cloud providers, right? So in that case, if Snapchat, or Snap in this example, had platformed their application on a platform like DCOS, they can very easily, if they needed to, move their data and their apps to other cloud providers. And the reason this is important is because a lot of the platform services that you'll be using will actually define your IT strategy as a company, right? Because if you're going with one cloud provider, you're going to use whatever toolkit's available from that provider, and that's all you're going to have. So what if there's a new machine learning tool or a new data science tool or a new message queue that you want to use? You're going to have to wait for that cloud provider to give it to you, right? And the other thing I'll mention is platform services, clouds are highly profitable businesses. So for example, Amazon's e-commerce margins is around 2.9%, I understand. Anybody know AWS's margins? Who guesses more than 10%? Okay, more than 20? Okay, so I heard it's like 29 or above 25%, right? So AWS isn't growing fast because they know how to rack and stack servers very well. It's because they're providing these platform services that do all the automation for you, which is great, right? But if you're a larger organization that wants to have architectural control and the flexibility to use any infrastructure, then a platform like DCOS could probably really help you. Additionally, if you're choosing to be on AWS, a lot of our customers, Autodesk has a blog where they actually talk about saving 66% on their AWS costs just by sliding in the DCOS platform in between. Because we do a lot of distributed workload pooling, which we'll show you when we get to the demo. So that's our approach at Mesosphere, right? Giving the ability to run any platform service from an open partner ecosystem, and through automation, allow you to run that in any infrastructure. And the core of our platform is Apache Mesos, which is a distributed system scheduler that aggregates the underlying resources and presents those resources to all the workloads on top that can use their own scheduling logic to run the workloads that they see fit. And the benefit of this is that DCOS allows you to abstract, pool, and automate distributed systems the same way virtualization abstracted, pool, and automated monolithic apps on servers, right? So instead of running Cassandra, Kafka, Kubernetes, Marathon on different clusters, you can have one elastic infrastructure that shares all of this for you. So you're going to save a lot more money with higher utilization. You're going to simplify your operations because people are creative, and when you create different clusters and different people are building it, what happens? You start having snowflake implementations, right? And what works on this cluster might not work on this cluster. Oh, this guy left the company. How did he configure this cluster? What were his practices? Nobody knows, right? When you're using DCOS, all of this is automated because all of those services have definitions within DCOS that includes how to operate, how to scale, how to maintain, and how to provide high availability. And the secret to this is the two-level scheduling architecture within Mesos. We like to call it application-aware scheduling. The way it works is Mesos does one thing and does it really well. It aggregates the underlying infrastructure resources. So it answers questions like, how many CPUs do I have? How much memory? How many cores? How many of those processors are GPUs instead of CPUs? So Mesos knows all that and knows how to present this to the workloads on top. The workloads on top, because they're distributed systems, already have their own schedulers, right? So Kafka will know, hey, or Cassandra, for example, might say, hey, in the best case scenario, I don't want my different Cassandra nodes, or I don't want my different Cassandra agents sharing the same node because I want them distributed for better protection. Or Spark might say, I don't care where it runs as long as it's easily accessible so I can launch my analytics. HDFS, Kubernetes, there'll all be different logic on how you schedule it. How do you do high availability? Right? So for example, if you're running a stateless container and the app crashes, you could just launch that container anywhere because it's stateless. But if you're a Kafka broker, you're storing data locally. So if that goes down, a human would say, I want to start that Kafka broker again on that node to access that data that was already there. All of this is automated with DCOS. And it's because we are able to create these frameworks that encapsulate all the logic, all the best practices of those data services. We have a joke at Mesosphere. We like to say, all startups are trying to disrupt somebody, right? So we're trying to disrupt O'Reilly from selling those big animal books that tell you how to run all these services. Just kidding. I'm a fan of O'Reilly's, but that's just what we say. So that's how two-level scheduling works. So if a new version of Spark comes out, we can very easily add Spark to our ecosystem. It's just Kafka, for example, in our latest release, just about 100 or so lines of config information defines that service and how it runs on DCOS. So if a new version of Kafka comes out, we can very easily adapt it to our infrastructure. Does that make sense? Okay. So enough talk, right? Let's see how this works. So I'm going to do a short video, and then later we'll actually go into the demo. But first I want to just show you guys how this actually automates the installation of these services. So this is a DCOS. You log in, you'll notice that you'll see a bunch of nodes, because we call it the data center operating system because you don't have to worry about where stuff is running, right? You don't have to worry about where your browser runs, like which core in your laptop it runs when you launch it. Why should you care which of these 20 nodes a distributed system is running? So that's the logic behind the data center operating system approach. So who's installed Spark? Okay, or Kafka? Okay, Cassandra? Okay, wow. Was your experience like this, installing, so let's install Kafka next, or Spark actually. So right, you click install, click deploy, accept, and there it is, it's happening, right? You go get a cup of coffee, you come back, it's done. Kafka, let's say you're doing an IoT project. You need 10 brokers, not just 3. Okay, go to config, change it to 10 brokers. Come on, type faster, right? Click deploy, you're done. So DCOS will take care, it'll take a little time, right? But it'll take care of all of this for you. And then, meanwhile, I'll show you our catalog. We have over 100 services at this point in time. Some of them are services that are built by our commercial partners like Lightbend, Confluent, DataStax. Some of them are open source from the community. So overall, we have 100 or so services. So let's say, okay, Ed, that takes care of the data services portion, but what about container orchestration? I'm really big on Kubernetes and I want to run it. How do I do that? So I'll show that next, but before I do that, notice how Cassandra is running on 2 different nodes, a third node will launch soon, Kafka's already on 9 different nodes, Marathon, the native container orchestrator within DCOS, is in 3 different nodes. All of these are sharing infrastructure, and you as an operator don't care where it runs. And if something fails, DCOS will relaunch it in the way that's consistent with the best practices of that distributed system. Who's installed Kubernetes? It's hard. Yeah, we had a Kubernetes engineering lead at MesosCon saying, Kubernetes is great, but it's hard to set up, especially if you're doing it on-prem. So we just did that, by the way. I don't know if you noticed on the UI. You click deploy, and all the processes required to get Kubernetes up and running are getting installed. I did shorten this video by about 40%, so it takes a little bit longer than this. But you can see all the etcd, all the other things that you need to get Kubernetes up and running is actually going to get set up. And once this is done, you can use 100% open source upstream Kubernetes on your DCOS cluster, shared with the rest of your infrastructure. So I think we'll show you that next in the video. These are all the nodes. Click grid, click show services by share. So you'll notice Kubernetes is purple here. It's running on 8 or so different nodes. You can see that Cassandra, the blue one, is now in, oops, all right. It's in 3 different nodes. They're all sharing the cluster, right? So this is how we accelerate time to market of services that you're building, and we also help you save money. And the same is true if you wanted to scale Spark. It's actually just that easy. So let's kind of keep going here. So sometimes we get the question, well, you guys do container orchestration at Mesosphere, right? And the answer is we enable container orchestration with one of the projects that we do. But our main thing at Mesosphere is not container orchestration, because container orchestration is actually slightly different than resource aggregation and application-aware scheduling. And I'll show you what that means. So we all know about 12-factor apps and how it's best practices, right? One of the themes, I guess, about 12-factor apps is to use backing data services. But it's not very prescriptive on how you run backing data services. So in the DCOS approach, we treat backing data services as a first-class citizen of the things that we need to manage and operate. So we have to automate data services the same way we automate containers and microservices. Whereas a container orchestration approach, it's focused on the containers, not on the backing data services. So what we do is create frameworks. We create services that will do the actual orchestration of the container and frameworks that will do the automation of the data services. And then we provide an underlying resource aggregation that offers those resources to those green things on top. Right? So Mesos on the bottom just knows what to run or what resources are available. It knows whether you have GPUs or not. Right? On the data service side, let's say a data service wants GPUs. It knows to ask for GPUs. Right? So this part will ask this part for stuff. This part will offer this part for stuff. And that's it. And we think of this as very analogous to the components of an actual operating system. And that's why we call it the DCOS. Now, how does this compare to a container orchestration approach? Well, in a traditional or common container orchestrators, it's doing the container orchestration and resourcing together. So, the runtime, how it's scheduling the containers, it's one thing. That's not a bad thing if all you're doing is containers. But if you're also going to be using data services to power those containers for data persistence, for connectivity between services using Kafka, for analytics, this approach on the left is going to help you a lot more, right? From running siloed infrastructures with manual operations. Sometimes we get the question, well, so what are you most comparable to from a technology perspective if you're not saying you're a container orchestrator? And I'll admit, that answer is a little bit complicated because the best I can figure is this infrastructure looks a lot like what you would see in the Google Cloud or on AWS. Right? So for example, when you run Kubernetes on Google Cloud, it's not on physical infrastructure. Right? They have something that they call Google Borg, their underlying resource aggregator on which you run Kubernetes. AWS they don't share too publicly about what they have running down there, but all those services are on some internal proprietary AWS resource manager. And so we do something similar, except ours is open source. DCOS is an open source project. We allow you to run all these different data services and container orchestrators, Kubernetes or Marathon, on the container orchestration side, and a set of data services on the right. And then Mesos does the resource aggregation. So that's the analogy. And then with this approach, you can take this whole stack with you to any infrastructure you'd like. So container orchestration engines have actually had a long history on Mesos. So Aurora, first used at Twitter, was a container orchestrator that was built on top of Mesos when Twitter used Mesos to deal with the fail whale. Right? So Justin Bieber used to tweet a lot, lots of followers, crashed Twitter. It played a big role in how Mesosphere was founded because our co-founder was at Twitter at the time and had to deal with this Justin Bieber problem. And he was good friends with Ben Hyman, who invented Apache Mesos, and that's how Mesos got used at Twitter. Right? And they used Aurora to do the container orchestration. Mesosphere, when we were founded, we created Marathon, open source container orchestration. Actually, the first container orchestrator, I think, to do actual Docker containers. And then since then, we've seen folks at Apple, Netflix, build their own proprietary container orchestrators on top of Mesos. And we actually announced a couple of months ago that Kubernetes is now available in beta on top of Mesos as well. So that's what DCOS does. Now, in terms of the data services, right, Mesosphere's DCOS gives you a cloud-like experience for running these data services. So you guys just saw how easily we install Kafka, Cassandra, Spark. Similar to the things you might see on AWS, we have the open source equivalent available. And if you want to work with the commercial entities behind these open source projects, we work closely with them as well. So Kafka, the commercial entity behind them is Confluent, DataStax for Cassandra. Lightbend is one of the commercial entities that work on Spark or provide Spark services. So a lot of options are available to you. But there's more. Right? It's not just containers. It's not just data services. A lot of people are actually also using Mesos to run traditional applications. So this came out of a survey we did last year. We're doing another one later this year, where we asked over 500 respondents, what type of workloads are you running on Mesos? And this is what came back. Right? Vast majority running containerized microservices, a majority of them running data services like Spark, Cassandra, Kafka, and a lot of them, over half, are actually running traditional monolithic apps. And the benefit of using Mesosphere's DCOS is you don't have to containerize it. DCOS will containerize it for you when you launch it. So those are the technology kind of implications of a DCOS approach. I'll talk a little bit about the business impact, because part of your roles as technology and architectural leaders is to explain to your constituents or managers, right? You know, what does all this technology mean for your business and implications for your IT strategy? And in a nutshell, people use Mesosphere and they pay us for our enterprise product for three main reasons. First, we accelerate time to market. You guys saw how quickly we install those data services, right? That thing has huge implications if you're trying to create a new IoT project or a new connected car project. And that's why we have customers like Verizon, JPMC, Royal Caribbean. All these folks are trying to launch innovative new services, and we help them accelerate time to market. The second piece is saving money, right? So if you're running distributed systems, Mesosphere's DCOS helps you pool those workloads, drive up utilization, and save a lot on infrastructure costs. Additionally, there's a lot of automation. So scaling, high availability, upgrades are as simple as how we showed you the installation was just now. And then lastly, providing resilience and security. So security is part of the feature set that's part of our DCOS Enterprise Edition. So that part is not open source, whereas DCOS itself is open source. Those include things like role-based access control, multi-tenancy, Active Directory integration, secrets management, so that your microservices can talk to each other using secrets that are not in a repo somewhere, so you can have more security in your application. And because of this, a lot of customers choose to work with Mesosphere. So we have over 25% of the Fortune 50 companies using our platform. 5 out of the top 10 banks in North America, JP Morgan is one of them. 5 out of the top 10 telcos worldwide, Verizon is one of them. And 5 of the 10 most valued startups. Startups is Uber. Is Uber a startup? I don't know, right? But some people call them a startup, and there was a list that kind of teed up, we're the most valuable startups in the world. And so we looked at them and we noticed, 5 out of these top 10 are actually our customers. And then lastly, connected car infrastructure. Companies like Audi, there's many companies that are building infrastructure so that cars can talk to cities, so cars can communicate with each other. They're finding a platform like DCOS very compelling to build their next generation infrastructure. Is that useful for you to communicate with your constituents within the organization? So here's some highlights, right? So GE Digital, Darren Haas, a huge champion of our platform. They're using us for Predix, is my understanding. Audi's actually been at MesosCon talking about how they're using our platform. Royal Caribbean, not the first company you think about when you talk about digital transformation, but they're doing some exciting things around ship-side edge cloud, which I'll talk about in a minute. And then 2 Sigma is a quantitative hedge fund based in New York, and they're doing algo trading, batch analytics with real-time day trading, and aggregating all this and running at over 90% utilization. So very impressive stuff that they're doing there. So we have many companies, many customers across different verticals, open source project users, as well as commercial software users. We have well over 100 customers, enterprise customers at this point, using our software, including some government agencies that are doing things that I probably don't even know about. So this one is an example of one of these major banks, right? So they're creating a strategic innovation platform so that they can very easily adopt new technologies, right? This bank was one of the first to use Hadoop, for example. But now they're realizing that there's also a lot of other next generation data services, container orchestration engines. And how do you make sure that all the different BUs have easy access to these services? Because I think we'll all agree, just getting VMs on demand doesn't cut it anymore. You have to get these services so that the developers can build their apps, so that the cybersecurity team can use Kafka to track network traffic and look for anomalies, so that the retail banking division can use Spark to identify customer interactions that might be useful for an upsell. So these are all things that this leading financial organization is trying to do. The next one, major cruise line, right? So Royal Caribbean was at MesosCon. They had representatives at MesosCon talking about what they were doing. And it's actually quite exciting. So I I haven't been on a cruise for a while, but apparently, instead of giving you daily pamphlets on what's happening, it's all on your mobile device now, right? So they want to create a seamless experience between how you book a cruise, how you experience the cruise, how you order upgrades to different meal plans and so forth. And to do that, you need to have customer information, inventory of how many Wagyu beef steaks you have left, that kind of stuff. All that has to be synced, right? So you have to plan campaigns that you want to run, and then make sure those campaigns are being executed in the ship-side edge cloud. And because this satellite link is primarily used for people Skyping with their grandparents when the ship is out at sea, they can only do this transfer when the ship is in dock. Right? So this is an example of a global service with data locality because of this latency or communications gap that they have to deal with. But we have auto companies doing this with mapping information that can't leave a geographic territory, or a banking institution that can't take data out of a certain geography when they're doing ETL. Many, many examples of this edge computing using DCOS. Okay, that's enough talking. Let's see a demo, right? Okay. Randy, do you want to use this laptop or this one?
This one.
Okay. So let me ship over
this one. I like this one's color better.
All right.
So let's get this plugged in, and
This is not. It's connected.
yeah,
Right?
can you grab that? That'd be great.
Let me just roll it. Because you have one slide.
Right. Yeah.
Okay.
We're gonna go to that.
Okay. So,
There we go. We're good. So I've seen a number of you actually come by our little area, and I just love talking about infrastructure because personally it's my background. I've basically spent nearly 20 years doing infrastructure in very large companies prior to doing kind of vendor work as I am. Prior to this, I was at VMware for 3 years. I've been at Mesosphere for 10 months, by the way. And prior to that, I was at Abbott Laboratories for 11 years doing infrastructure. And we had about 16,000 servers, and we had a network that spanned 140 countries. And so I'm used to thinking ahead 6 months to a year and answering the question, what kinds of infrastructure will I need in order to really meet the needs of all of the business systems that we have running? And I like thinking ahead because, a lot of times we get so wrapped up in solving today's problems, we want to start thinking about, okay, how can I bring in infrastructure that can really handle the issues that I'm facing? The demo that I have running right now is a connected car demo. And part of the reason I have that, because I know that not all of you are dealing with maybe IoT type of issues where you have a steady stream of data coming in, is that it demonstrates a data flow from when you have data coming in, whether that's from users or connected cars or IoT devices or whatever you need, to a Kafka queue, as you can see right here in the corner. It goes through an ingester and validates the messages in this whole microservice architecture like we're supposed to be doing, according to the 12-factor apps manifesto? I don't know. I think that's what I would call it.
Yeah.
And we're doing data analysis against it. We're also storing it in a Cassandra backend database. Now, the interesting thing about Kafka and Cassandra from an architecture standpoint, there's probably some of you that know this really well, but just to be clear for everybody, is that they're horizontally scalable. And that's really great because when we start dealing with the data needs of today, this data is not coming at us at the speed of human beings, which are clicking on things. It's coming from devices that are constantly sending data to us at the speed of machines. And so I've found it fascinating in my time at Mesosphere as we start talking about this type of architecture, because I'm talking to one manufacturing company that said they had something like 150,000 devices in manufacturing plants in some 40 locations around the world. And they had to deal with this huge amount of data side by side to the microservices they have and the data analytics that they want to do against it. So when you're taking a look at this demo, we're really demonstrating each one of these types of factors as we go into it. And Let me bring that up. So right now we have this connected car demo. We've got some cars running around in the Bay Area, in fact. And each one of the data points that you see right here represent a longitude and latitude and engine temperature and a few other pieces of information, which is neat. That's kind of cool and all, but the interesting thing to me always is, well, how am I dealing with this data? How am I pulling it into my system? So you're looking at the live Kafka queue right now from those cars, sending the data out, and the data is winding up eventually in a Cassandra database. Let's just limit it to 10 rows so that we don't have to look at every single piece of data. And what we're doing right now is storing this, again, in a horizontally scalable database that replicates between each of the nodes. So why do I keep emphasizing that? When you have horizontally scaling needs, you need a cluster that can handle that on an as-needed basis. I mean, the last thing you want to do, let's face it, is to buy more infrastructure every time you want to do it, or spin up more VMs and go through either your procurement process on the licenses that you're going to need for every OS that you're spinning up, and maybe dealing with all of your inventory. I don't know about you guys, but when I was at Abbott Laboratories, we had an inventory database. We had to deal with patching. We had to deal with antivirus and a whole host of other monitoring needs. That goes away when you start to actually carve this thing up into microservices. So if we take a look at the dashboard, now we're looking at a live cluster that we have right here. And as you can see, we have 23.22 of 40 shares. Now those shares are cores. And the cores are spread across all of the nodes that you see here at the bottom. We have 10 nodes right now. It's a little easier to see in grid view, so let's take a look at it and segment it out. For each of these cores, or each of these actually nodes in this case, I have a number of cores associated with it. I really shouldn't have to care about any of it when I'm dealing with my services. So if I go back to my services list right here and take a look at what I have, I really shouldn't have to worry about the fact that, for example, with Kafka, that I have 3 brokers, as you can see here with this. And the brokers, it's probably difficult to see from a distance, are all on different hosts. Why is that important? Because I don't know about you guys, but as an architect, I always had to make sure that I had an HA configuration out of the box if I thought through it ahead of time. That one-click install that we saw earlier, that already has this built into it. So it's already making sure that it's an HA configuration. We also never had to specify which nodes to run it on because the decisions were made by the OS itself, the DCOS itself, as you did it. The same is true of Cassandra, the one that we were looking at where it's just storing the backend database. Again, HA configuration out of box. Again, if you need to scale this larger because you have another manufacturing plant that you put online, you can expand it out. You just have to go through the needs of whatever the application is. In Cassandra's case, you have to go through a little more effort to expand it, but the infrastructure is there and waiting for it to go. So when we're dealing with this type of thing, that's also true of the microservices that you have running on it. The actor is one of the it's actually the connected cars simulator. So each one of these is taking it from a data set. And these are just based on a Docker container. And from the point of view of what we're seeing here, this is actually, oddly enough, what I get most excited about. It's not a GUI front end, but it's the JSON file that represents the application that I developed. In this case, it's an Akka, like I said, it's just an Akka actor. And it specifies the amount of CPU that it's supposed to have, which you can see is 1/100th of a slice. So you don't really need to get very large for some of these things. The amount of memory that it has, the network, the health checks that are needed. And by the way, if the health check fails, the operating system itself, the DCOS operating system itself, is what kickstarts it. And it kickstarts it whether you lost the node that it was running on or if your application failed. I like to say that even if you have an app that, for example, fails every 20 minutes for some reason, DCOS would make sure that it's running because every 20 minutes it would just start up another one. And if it's a networked application rather than one that's generating data as this one is, the load balancer will automatically cut off the old one and add a new one as soon as it appears. Your end users won't even know it, which means that we, in some cases, can cover for some bad coding. That can actually happen in this case. Auto-scaling is also something that's fairly easy to automate. So, of course, we're going through the GUI for this one, but you can also use an API or CLI to do the same thing and say, hey, I just want 10 nodes, or quite a few more than that. Might have clicked even more than that. And immediately we're running on a whole host of systems all across this entire set of nodes with ready infrastructure that's waiting for it. Of course, if we go back to the Kafka queue at this point, it's going to be a heck of a lot more fun because we have more data coming across it. So,
Do you want to go back to the map and the drivers just so people see that?
This one is connected to this one. It's connected to a different map, so don't worry about it.
Okay.
Yeah, so we can.
So
back to
what you guys just saw Randy do was just very easily scale the number of cars on driving around in the San Francisco Bay Area from 4 to 20, right? Just by clicking a button. So adding more devices to your application, scaling up the number of actors. If you need to scale Kafka, Spark, Cassandra, and so forth, all very easy, either with the GUI or programmatically through the API. And that's kind of how DCOS helps you very quickly launch an IoT project in this example. If you're in a toothbrush company and somebody comes up with a Wi-Fi connected toothbrush and all these value-added services, if they go to the infrastructure guys, the answer won't be, well, let me provision those clusters for you and get back to you in about 6 to 8 months. So that's the DCOS approach. And the last thing I'd like to close on is open source software. We are a open source core company. So we're one of the main commercial entities behind Apache Mesos. We created the open source DCOS project. The reason why open source is important is because I strongly believe it's important for innovation. When I was an engineer at Oracle back in the .com era, I don't think open source was such a big thing, right? So when I came up with some patents and I got $1,000 per patent and then I went on my way. I wasn't able to champion that technology or see it go anywhere. I think that world's really changed, where developers are really empowered and they can create projects, and if it takes off, have a lot more impact with the technology. And then also, as a company, you can use open source technology that's created by others, right? The challenge, of course, is it's gotten really complicated, right? A lot of open source projects, and a lot of them, again, are distributed systems. So Cassandra came out of Facebook, Kafka came out of LinkedIn. All these are companies that are putting a lot of resources to build these technologies, and if you don't know how to master those distributed systems, you can't even take advantage of those things. And that's what DCOS can really help you with. But if we can't manage that complexity, what's going to happen, you guys think? If open source software continues to be complex, I think we might all know the answer to that, right? It looks something like this. So AWS has actually done really well because they make things super easy. Think about a long-term view where small commercial entities that are champions of open source software are not able to put those technologies in the hands of businesses to use them. And the businesses instead just choose a cloud provider and use whatever services are available there. That's not a bad thing, but if that's all people did, we will see likely a lot less innovation in open source software, right? And the major dynamic on these platform services will be around how the cloud providers interact with each other, right? So in some cases, some cloud providers focus on open source, right? They'll say, hey, we're going to build a cloud and we're going to create an open source ecosystem, and you can run anything you want on top of that. In other cases, cloud providers might go, we're going to make all the services proprietary. We might even use open source code to power that service, but we're going to use APIs that are unique to us because we want the workloads to stay with us, right? And so that's kind of the future of open source. If we, as a community, don't make it easier for companies to adopt multiple open source projects together to get to a business outcome. And so how do we ensure this thriving ecosystem? I think the key is how the open source community and the commercial entities behind them come together. Sometimes I think some open source project-based companies, they don't realize that their main competitor is not other open source projects necessarily. It's actually people whether choosing to use the technology at all versus using something that's unique to a cloud provider. And so and one example of this is we all know what the LAMP stack is, right? LAMP stack enabled a new generation of web applications that allow users to contribute content. So instead of building my own HTML page to build my homepage, like in college, I could just use a web service, right? Or use Facebook or whatever. And the reason the LAMP stack took off and had the impact it had was because all these components were open source, right? People can use it, and if they needed, there were commercial entities that supported these components and built their businesses on top of this open core. And we're definitely seeing something very similar today with what we like to call the SMAC stack. Because a lot of our customers at Mesosphere, they're doing data ingestion at scale, analytics at scale, distributed persistence on a horizontally scalable platform. All of these are distributed systems that require a distributed operating system, which is what Mesos on DCOS does. So just the same way Linux helped enable the LAMP stack and simplify and bring it to the masses because you're not buying a lot of OS licenses and so forth, the SMAC stack is doing something very similar to solve a whole new generation of application challenges that are customer-centric and data-driven. And for each of these, there's commercial entities, right? So Confluent, Lightbend, Kafka, DataStax, Mesosphere for Mesos. We all have to come together and build solutions that are easier to use. And SMAC stack, by the way, is just an example, right? I don't say SMAC stack because I really want you to only use Cassandra and not some other database. That's not my point. My point is when you're talking to your constituents within your organization and helping them understand the power of these technologies, they need to see the whole picture, right? And by communicating this way, you can help them do that. And so that's why when we launched DCOS in 2015, a year after we actually open sourced it, and we were able to very quickly grow from about 40 to now well over 100 different services that are available on the DCOS platform. Right? So we're taking technologies that were proprietary at Google and Facebook. That's what Mesos did. It was if you had to build these architectures in an open source way, what would it look like? And that's what Mesos was. And we made Mesos a lot easier to use. In fact, a survey that we did said 87% of all new Mesos users are doing it with DCOS because we make it that easy. A lot of the components that you need, capabilities are built in. And then now we're working with commercial entities of these open source projects to make sure those solutions come to you a lot more easily. These are just examples of the types of workloads and the types of frameworks people are using on Mesos. A lot of different types of technologies coming together. And also the flexibility to run on-prem, in the cloud, or a combination of both. And then the types of clouds people are using is clearly reflective of cloud market shares currently. And one example is Lightbend's Reactive platform, right? Or fast data platform, right? The foundation of which is actually Mesosphere's DCOS. Right? So we're happy to work with Lightbend and many of other commercial entities to come together and build solutions that are easier for our customers to get to business outcomes. So that's the presentation. We talked about how application architectures are changing. We talked about how it's important to enable a cloud-like experience, ideally on any type of infrastructure. You saw through DCOS demo that Randy did how we're able to help you quickly spin up and automate a connected car infrastructure as an example. And then lastly, DCOS plays a key role in helping us to grow an open source ecosystem to encourage innovation. Otherwise, we're going to have a future where the only technologies available are from Costco and Walmart, right? You won't have choices on what you use. So that's all we had. We'll be here for any questions, and thank you very much.